the layers of this are, we need to know the formula. So if you don't know the formula, go to the formula sheet. You need to understand there's parts to this formula, and you need to understand you need to choose some parts. So you need to first of all choose the parts u and dv. Okay, so the original integral has to have a u and dv part, and then we need to generate the other parts to be able to put it into the formula. So when I look at this function here and I try to integrate it, well, I don't know the integral of log x. That's not a standard integral. Okay. Later on, when we get more familiar with this, maybe we can consider this a standard integral, but at this point we don't know. We don't know the derivative. We don't know the integral of log x. We know the derivative. We don't know the integral. There's no standard integral for this. Okay, so then we try to do some substitution or rearrangement. No deal there, doesn't work. So the only other choice we have at this point is parts. So how am I going to split this into parts? The criteria is we select the dx part. That's the most complicated that we can integrate. Well, unfortunately in this part, if we select the log x with the dx together, if this is my dv, then I can't, that's my original problem. I can't integrate that. Okay, so the most complicated piece out of here that I can select for the dv is only the dx part. And remember, the dv must include the dx part. So that means the u must be log x. So then once we've decided on that, we need to generate the parts. So generating the parts, I differentiate the u to get the du part. I integrate dv to get the v part. Okay, so I've got all my parts here. If I look at my formula, it's going to be, my formula look like this. I'm just going to write it out here. It's going to be the integral of u dv is equal to u times v minus the new integral of v times du. Okay, so basically I'm starting with this u times dv integral. I'm going to end up with this one, and hopefully that one's easier to work with. Okay, so there's my original integral. So log x dx, that's equivalent to my u times v, so x log x. Okay, so maybe I'll do this in color coding this, x. Okay, so this is where my log x comes from, it's the u part, minus, okay, the integral of v du. So my v part is there, so there's my v. I already worked out my v integrated to x. My v part and my dx part is going to be all that part there. So it's going to be 1 over x dx. Now there's my new integral. Now is that new integral easier than what I started with? And the answer would be yes, because that's, first of all, that's going to just cancel out to 1. And so we're going to end up with the integral of 1 dx. Well, that's easy to do. Okay, so there's my original integral here. So this integral I started with, I couldn't do. The new integral I ended up with, I can easily do. Okay, so I get x log x minus the integral of just dx. So my answer to this integral is going to be x log x minus x plus c. Okay, so again, this is something new, so we should just check it to make sure that it works. So I'm just going to check it over here by differentiating. I can always check by derivatives. So d by dx of x log x minus x plus c, that's going to be the product rule, so log x plus x times 1 over x. There's my product rule. Derivative of x is 1 plus 0. That is a plus 1 minus 1, so I end up with log x. Okay, that's what I started with. Okay, so perfect. That is the antiderivative of log x, is x log x minus x. Okay, so that works, and we've checked that it works.